So last class we discussed how to analyze recursive algorithms and what is the general plan. It is similar to analyzing non-recursive algorithms. The only difference is in fourth step. In case of non-recursive algorithm, we will get a summation expression, but in recursive algorithms, we get a recurrence relation. Here we get a recurrence relation. In both cases, there we simplify it. Here we solve the recurrence relation and find its order of growth. After that, we can represent it using some asymptotic notation. So now, what is this algorithm? This algorithm we have already discussed now. So what is this? It's a linear search algorithm. So what is the difference between this variant and what is the other variant which we discussed? What is the difference? It is what type of algorithm is this?
Recursive.
This is recursive. We discuss non-recursive case. So now you tell me what is input size parameter? What is input size parameter? We are given an array of n elements. We are looking for a key. What is input size parameter? Similar to previous one, here also input size is n. Now tell me what is most important operation here? What is most important operation here? What is most important operation here? What is most important operation here?
Function calls.
No, the operation of so according to RAM model of computation, function calls or loops, they are not considered as simple direct operations. No.
It is a comparison operation.
It is a comparison operation. What is that comparison actually?
A of n is equal to key.
A of n equal to key. So here the most important operation, we can consider this as most important operation. There also same thing we consider, no, first, whether a of I not equal to key or not. Here a of n equal to key. This we consider. Okay, this we can say it as most important. So here also it is comparison operation. It's an operation. Now let T of n be the number of times comparison operation is performed when n is input size. When n is input size. Does it depend on n, only on n, or actual values in the input also? Actual values in the input also?
Actual input also.
Actual values in the input also. For example, 1, 2, 3, 4. This is 30. This is 5. This is 35. 38. This is 12. In this case, our key is 30. Key is 30. N equal to 4. How many times this operation is performed? A of n equal to key operation. How many times it is checked? It is performed how many times? How many times? How many times this operation is performed?
4 times.
No. So this algorithm, you please check this algorithm. The variant which I have given here, according to the pseudo code given here, how many times this operation is performed? First n.
2 times, sir.
So our function call, initial call is
4 times.
Initial call is linear search array name n, whatever be the value of n 4, it is 30. This is our initial call now. First, what does it check? Whether 4 equal to 0 or not, it checks. So it is not correct. Else condition, it checks a of 4 is it equal to 30 or not? What is a of 4? 30 equal to 30. It returns 4. It returns 4. So now how many times this operation is performed in this case? How many times this operation is performed? Okay, this is
only one time.
This is written n, not I. This is n. This is n. Okay, this is it. Only one time it is performed. No, only one time it is performed. But if our key is 12, how many times it is performed? Same input, key is 12. Key is 12. How many times it is performed? How many times it is performed? How many times the operation is performed?
4 times. 4 times.
4 times. 4 times. It is performed. That means for same value of input size, number of here t of n equals to 1, here t of n is 4. So that means for the same value of input size, number of times basic operation is performed, it is different. So it depends on n also, instance also. It depends on instance also. If it depends on n as well as instance, then what is that we need to calculate? We need to calculate under different cases what are its running times. So hereafter we calculate only worst case running time, best case and worst case running times. Okay. Now tell me what is best case running time of this algorithm? What is best case running time? What is best case running time? In the best case, how many times comparison operation is performed when n is input size? How many times comparison operation is performed? When n is input size, the total time this algorithm takes, I denote T of n. When n is input size, how many times that operation is performed?
Best case it is one, sir. Order of one.
T of n is 1.
One.
That means what? N power 0, order of growth is n power 0. Correct? Order of growth is n power 0. Hence, we can write it as best case running time is order big O of 1. We can also write it as big omega of 1. We can also write it as theta of n, theta of 1, theta of 1. Is that correct? Okay. Similarly, tell me what is worst case running time of this algorithm? What is worst case running time of this algorithm? What is worst case running time? What is worst case running? Let T of n be the time this algorithm takes when n is given as input. When n is given as input, is that okay? So time is T of n. So when n is given as input, it checks if n equal to 0, it returns -1. Otherwise, it compares it one time. After that, it calls the same function, but with input size n-1. This is input size, no? Input size n-1. That means what? What is the time this function takes? Here one comparison we are performing. After that, it is calling the same function, but here input size is n-1. So that means what is the time it takes? When input size is n, time it takes is, when input size is n, the time it takes is T of n. When input size is n-1, what is the time it takes?
T of n minus 1.
T of n-1. Now tell me what is the reconciliation for worst case? What is the reconciliation for worst case running time? T of n can be written as 1 plus 1 plus 1 plus. Again, we call this function, no? We call this function T of n-1. What are initial conditions? This is if n is greater than or equal to 2. N is greater than or equal to 2. If there is only one element, how many times this operation is performed? A of n equal to key operation. If there is only one element, how many times A of n equal to key operation is performed?
Only one time.
Only one time. So now this is our reconciliation. This is our reconciliation. Please, all of you solve this reconciliation. All of you solve this reconciliation. So our reconciliation is T of n is T of n-1 plus 1. Now what is T of n-1? this we have
T of
all
n
know
minus 2
similarity.
plus 1
T of n minus 2 plus 1.
plus 1
Already plus 1 is there, that we write.
plus
It
1.
becomes T of n minus 3 plus 1. Already 2 ones are there, that we will write. And next it becomes T of n minus 4 plus 1. Already 3 ones are there, that we write. And this one, after I steps, it becomes T of n minus I plus 1 plus 1 plus 1. How many times? How many times?
I times.
I times. I times. So that is, it is nothing but T of n minus I plus I. But we know value of T of 1 only. So that means n minus I, if I take it as 1, that means what is I? It implies I equals to n minus 1. So now at I equal to n minus 1, what is this value? What is this value? T of n minus 1 plus n minus 1. So what is this? T of 1 plus n minus 1. What is T of 1? 1. 1 plus n minus 1, which is nothing but n. So therefore T of n is n. T of n is n. What is its order of growth? What is the order of growth of T of n? Order of growth of T of n. What is the order of growth of T of n? It is n only. Order of growth of T of n is n only. Is that okay? Order of growth of T of n is n only. Hence, we can represent T of n as T of n as T of n as T of n as big O of n, big omega of n, even theta of n. All are correct. Is that okay? So this is the recurrence for worst case running time. This is the recurrence for worst case running time. So even if you calculate this n equal to 0, this is also one operation. Then now this is also one operation. Then what is the recurrence for worst case running time? What is recurrence for worst case? Then we can write it as plus 2 here. We can write it as even plus 2. So that's why in general, even if you write T of n equal to T of n minus 1 plus some constant, still it is correct. And T of 1, either we can write it as 1, or this value also we can consider it as an operation. It may be 2, or it may be, depending on how we are counting, it may be 3 also. That's why T of 1 we can write it as constant, some constant. This is also correct. This recurrence relation is also correct. Is it okay? T of n is T of n minus 1 plus constant. That is also correct. T of 1 is constant. That is also correct. But running time, is there any change? Running time, there is no change. Best case it is constant. Worst case it is n. Worst case it is n. Now, so if I consider this, already we discussed the analysis of this recursive algorithm, that is finding factorial of a number. If we consider this operation as most important operation, then what is basic? This is our basic operation. Basic operation. Now you tell me how many times this operation is performed. When n is input, number of times it is performed, we call it as T of n. Now what is the reconciliation here? What is T of 0? What is T of 0? If n equal to 0, how many times that operation is performed? If n equal to 0, how many times that operation is performed?
1 time.
Only 1 time. So it is 1. If n is not equal to 0, that means here always we give input greater than or equal 0. If n is anything greater than 0, then how many times that operation is performed? Here first it performs 1 time, 1, plus after that only else condition is executed. Here again, what is the condition? This is same as recursive call. Here what is input value? N minus 1. N minus 1 means what is the total number of times this operation is performed? It will be T of n minus 1, 1 plus t of n minus 1 if n is greater than or equal to 1. Is that correct? Again, what is the value that we get here? What is the value that we get here? What is the value that we get? You tell me what is solution to this recurrence?
1 plus t of n minus 2.
Oh, okay, same thing. This becomes t of n minus 2 plus 2. Next on swan, it becomes t of n minus I plus I. Okay, t of n minus I. But n minus I equal to 0. That means what? I equals to 0. That implies I equals to n. At I equal to n, what is this value? At I equals to n, t of n minus n plus n. So it is t of 0 plus n. What is t of 0? It is 1. So we have got 1 plus n. So therefore, what is t of n in this case? Therefore, t of n is n plus 1 for all n greater than or equal to 0. So this is our answer. This is our answer. Now, what is its order of growth? Order of growth, again it is n only. Again it is n only. So therefore, t of n can be represented as big O of n also correct, big omega of n also correct, theta of n also correct. Is that okay? Is there any doubt? Is there any change in the running time, whether we take this operation as basic operation or this multiplication as basic operation? Is there any change? Is there any change in the running time? Is there any change in the running time of the algorithm?
No, sir.
No, sir.
No change. Okay, but in this case, in order to when actual amount of work we are talking about, this we can consider it as one operation. Again, this also we may consider it as another operation. Then it will be two operations. The amount of work here it is constant. Here also it is constant. So if you want to write it in that way, we can write t of n as t of n minus 1 plus some constant we can write if n greater than or equal to 1. Similarly, t of 0 we can write it as some constant. Here this is also correct only. If the recurrence relation is given something like this, is it wrong? For this algorithm, if the recurrence relation is given like this, is it wrong? Is it wrong? Is it wrong or not? No, still this is also correct. This is also correct. Only one value they are replacing with constant by taking into consideration other things also. Okay, this is also correct recurrence relation. Correct recurrence relation. But running time there is no change. Running time there is no change. Okay. So all of us know what is searching problem. We have already discussed now what is searching problem. What is searching problem? So we are given a sequence of n numbers, say a1, a2, an, and a value called key. And a value called key. What does searching problem ask for? What does this searching problem ask for? Find an index I such that key equal to a of I. Key equal to a of I. What does it mean? If our elements are 10, 15, 5, 12, 20, what does it mean? This is 1, 2. Key equal to 5. Then what is the answer it returns? What is the answer it returns? What is the answer it returns? If key equal to 5, what is the answer it returns? What is the answer it returns?
Index 3.
It is 3. If key equal to 5 returns 3, that is position of that. Position of that. If it doesn't contain key equal to 46, what is the value it returns? Minus 1. Minus 1. Minus 1. Okay. Now there are different ways of solving this problem. No, this different ways of solving problem. One simple method that we have already discussed, that is linear search. It compares elements from one side to the other side. Okay, now this side to one side to the other side. Okay, looking for key each time. Okay, that's fine. There is another searching algorithm. Okay, another searching algorithm. If the given array of elements, no, that the sequence of elements, if they are in sorted order, if they are in sorted order, if our elements are 10, 20, 30, 40, 50, something like this, it is in sorted order now. Now in that case, what we do is, this is a starting index P, this is ending index R. Starting index is P, ending index is R. What is that we find? What is that we find? In this case, P equal to 1, R equal to 5. So what is that we find? We find middle of this. What is middle of this? This is position 1, 2, 3, 4, like this. No, what is middle of this? 1 plus 5 by 2. 1 plus 5 by 2. Floor I will take. So it is 3. It is 3. Now third position, whatever element is there, that element we compare with key. Say our key is 20. Key is 20. Okay. Key is 20. We compare with 30. So it is small 30. Are they both equal? Are they both equal? No. If that is not equal, because they are in sorted order, so what is, where do I need to look for this element, this key 20 on the right side? Is it necessary to search for this key on the right side?
No, sir.
No. Yeah, all of you remember, no? Okay. It's no need to search for it on the right side. If key value is, say, for example, 46. If key is 46, 30 and 46 we compare. Now 46 is more than 30. Is it worth looking for 46 on this left side? Left side?
No.
It's not required. It's not necessary. No, why? Because elements are sorted. So definitely it is not this side. It is not this side. So that means what? Now here we have two cases. One is total 3 cases. If key is same as the element which is presented off of this middle position, if it is same as the element present at middle position, then we simply say that that is the required element. Okay, no? Otherwise, there are two possibilities. One is key is this, if I call it as Q. Q is P plus R by 2, say P plus R by 2, floor of P plus R by 2. Then what is that we get? In this case, we get Q equal to 3. We'll compare A of 3 with key. A of 3 with key. If they are equal, then over. What are the other possibility? A of 3 less than key is less than this, or key is greater than A of 3. If it is key is less than A of 3, then what is that we do? What is that we do? What is that we do? Only left side we search now. Only left side we search. If key is greater than A of 3, then only right side we search. Search this side, search this side. Okay. Is that okay?
Yes, sir.
Okay. So left side means what? What is the left part here? If middle part is 3, what is its left part? Or middle part is in general Q. What is its left part? If my array is from P, indices are from P to R, and the middle part is, say, this is Q. What is left part of this?
P to Q minus 1.
Left to means it is P to Q minus 1. Right means
Q plus 1
plus
to
1 to R. Correct, no? Q plus 1 to. So we search either in the left side of the array or right side of the array. It is all approximately half of the size of array. No? Size of the array is 5. Left side we have 2 elements. In this case, right side also 2 elements. It is almost approximately almost half of the array. Okay. Now let us see this algorithm. That's what. So we are given array elements. We are given an array which contains indices from P to R, P to R, P to R. If P is greater than R, then what does it mean? If P is greater than R, then what does it mean? This is starting index. This is ending index. If start index is greater than end index, what does it mean? What does it mean? There are no elements in the array at all, no?
Yes,
There
sir.
are no elements in the array itself. Is that correct?
Yes, sir.
Because array, there are no elements at all. If P
Yes, sir.
greater than R, array has no elements.
Yes, sir.
Has no elements at all. That means it is empty. That is the meaning, no? Whatever. Okay. If P greater than R, then we simply say that it is -1. Key is not present. So this is not present case. Not present. Key not present. Otherwise, what does it mean? P is, this is false means P is less than or equal to R. If P is less than or equal to R, how many elements are there? If P is less than or equal to R, how many elements are there? What does it mean? How many elements are there? If P is less than or equal to R, how many elements are there in the array? If elements are from P to R, total how many elements are there?
P minus R minus P.
I equal to, no, that is not correct, brother.
R minus P plus 1.
Again, same formula. P one element is there. P plus one element. R also one element. So what is this value? I equal to P to R 1. What is this value? Upper bound minus lower bound plus 1. No. So that means R minus P plus 1 number of elements are there. Is that okay? Number of elements. Is that correct? Is that correct? This R minus P plus 1, that I call it as N. So that means say there are N elements in the array. What is N? R minus P plus 1. Array has N elements. N elements. So then first we'll check. We'll calculate Q. What is Q? P plus R by 2. Why I have taken floor? Why should we take floor here?
Get the middle.
Otherwise what happens? If for example P equal to 3, Q equal to 8, then what is that we should get? We should always get an integer. No, we should get an integer. So that's why this 3 plus 8 by 2, it is odd number. So to get integer, I'll put this. So that what is the integer that we get? What is that we get? 5. Is that okay? Is that correct? Okay. Next we compare element key with element at position Q. Both are equal. Then we say that Q is the required position. Q is the required position. Otherwise, if it, what does A of Q less than key mean? It is which side? Left side or right side? It is left side or right side?
It is left side, sir. Left side.
Key is right side, no? Key is in this case. If A of
Yeah, okay, yes.
Yes, sir. Key is on right side.
right side. Right side means what is that we need to put? So this is what is that we need to write? This is P. What is that we need to write?
Q plus 1,
Q plus 1. Q plus 1
comma R.
or this is Q plus 1. This is R. Is it okay? Okay. So this is right side. This is right side. If it is left side means, if it is left side means, what is this value? P comma, this value is q minus 1. Is that correct?
Yes, sir.
P comma q minus 1 comma key. Is that okay? Is that okay? Okay. So this is left side. Now tell me, if n equal to r minus p plus 1, the total time this algorithm takes is t of n. The total time this algorithm takes when there are n elements, the time this algorithm takes is t of n. T of n. T of n. What input size is? What is input size here? N. What is most important operation in this algorithm? What is most important operation in this algorithm? What is the most important operation in this algorithm?
Third step.
Comparison, sir, less than comparison.
A of q equal to key. Correct now? If that's, this is the most comparing one element with of the array with key. This is most important operation now. This is most important operation. So this we call it as a comparison operation. Comparison operation. Let to T of n be the number of times comparison operation is performed. Let to T of n be the number of times this comparison operation is performed. Is that okay? Now tell me how many, whether it depends only on n, depends on n only, or it depends on input instance also.
Yes, input instance also.
Input instance also. No, it also depends on input instance. Why? Because if our elements are 10, 20, 30, 40, and 50, if t equal to 30, how many times this operation is performed? N equals 5, t equals 30, how many times this operation is performed? What is t of 5? 1. If, if our elements are like this, if key is say 20, how many times this operation is performed? A of q equal to key operation. If key equal to 20, how many times this operation is performed?
2 times.
How many times?
3 times.
It is performed 3 times. Correct now? 1, 2, 3, 4, 5. Initially p equals to 1, r equal to 5. So p is less than or equal to r. So q becomes 1 plus 5 by 2. So it is 3. We'll check a of 3. What is a of 3 equal to? P or not? What is a of 3? 20. 20 equal to 30. This condition is failed. So from this we know that 20 is less than 30. So that means which part will go now? Left side or right side? Left side or right side?
Left side. Left side.
Left side. Left side means what is p value? What is p value? Same. Q value?
2.
3 minus 1, that is 2. Sorry, this is r value, no, not q value. R value. Okay. Now p is not greater than r. That means this array is not empty. That means we need to search. So now what is q in this case? 1 plus 2 by 2. What is this value? 1 only. 3 by 2 is 1.5. Floor of 1.5 is 1. Floor of, now we'll compare a of 1 equal to p or not. What is a of 1? What is a of 1? 10. 10 equal to 30 or not. 10 equal to key equal to 20 now. 10 equal to 20 or not. This condition fails. So now which side we are in? Which side we are in? Which side we are in? We are in left side or right side? Right side. Right side. Right side means what is p value? What is p value? What is p value? 2 plus 1. R value no change. R equal to 2. Q plus 1 means 1 plus 1. So P equal to 2, R equal to 2. P equal to 2, R equal to 2. What is Q? P plus R by 2, no? 2 plus 2 by 2. What is this value? It is 2. It is 2. What is A of 2? What is A of 2?
20.
20. 20 is equal to 20?
Yes.
That means it returns value 2. That means total how many times this comparison operation is performed in this case?
3 times.
3 times. No? 2 times. No? Here it is 1 time. Here it is again 2 times. Here it is 3 times. That means same input size, number of times that operation is performed, it depends, it varies. It varies. Hence we have different cases, best case, worst case, average case, like this. Is it clear? So input size is n, basic operation is comparison. So it not only depends on input size, basic operation count, it also depends on actual values in the input, that is input instance. It also depends on input instance. Then we will have different cases. Okay, this is an example. This is an example. Is it correct or not? Whatever is given. T of n value, you please tell me.
Not audible.
Is that correct or not? Is that
Correct,
correct
sir.
or not?
Correct, sir.
This is right side. This is left side. Left side means this is P2 Q minus 1. P2 Q minus 1. Okay. Okay. Now is it clear why T in this case why T of n equal to 1, in this case why T of n equal to 2, why T of n equal to 3? These two cases we discussed already, only this case. Okay. Now you tell me what is, now we have different cases. What is best case running time of this algorithm? Best case running time. What is best case running time of this algorithm? What happens in the best case?
First case, sir. First case.
This is best case, no? This first instance, no? This is best case. Best case. Is that okay? Now the same thing, okay, this is input instance 3 here. Okay. Same thing, instance 4, 20, 30, 35, 45, 50, and key equals to say 32. Key is 32. How many times this operation is performed? You please tell me what is, in this case, what is T of n?
Three, sir.
It is also
Three.
3. It is also 3. Correct? No? It's also correct. Now you tell me what is best case running time of this algorithm? What happens in the best case? The element at middle position, that is our key. That means how many times that operation is performed? Comparison operation?
1 time.
One time. So T of 1 equal to 1, we can write like this. Is that correct? T of 1 equal to 1 over what is its order of growth? 1. 1
N
means
raised to
0,
0,
0. That means it is constant. Is that okay? Is that correct? Now, so you are only counting this. That's why you are writing 1. If somebody asks like this, here also some work we do. Here also we do some work. Here also this is one work. So in that case, if you really are very much specific about that, we can write it at T of n equal to some constant, so that it takes care of all those things. Is that correct? Is that correct? Both are correct values of T of n in best case or not? Both are correct values of T of n in best case or not? If it is constant, what is its order of growth? What is its order of growth? It can be, what is its order of growth? If T of n is
1.
constant, what is its order of growth?
1. 1 only.
What is its order of growth? N power 0. Constant means it can be 5 or 10 or 3, 4, like this. What is its order of growth? T of n is 5. What is its order of growth? What is its order of growth?
Power 0.
That is also n power 0. No, that's what we discussed. No, if T of n equal to 20, what is its order of growth? 20 can be written as 20 into 1. This can be written as 20 into 1. It gets cancelled. So its order of growth is again n power 0. That's what we discussed. So this is about best case. What is best case running time of this by this one? T of n can be written as big O of 1. Is this correct or not? Is that correct or not? Is that correct or not? T of n is theta of 1. Is this correct or not? Both are correct. Now you tell me what happens in the worst case. What happens in the worst case? What happens in the worst case? You tell me what happens in the worst case. Either we search on left side or right side. Every time it happens like that. Every time it happens like that. Every time it happens like that. Finally, if an array size is n, loosely speaking, when we go to left side or right side, array size becomes n by 2. Again, when we go to left or right, it becomes n by 2 by 2. No. Again, if you go to left or right, it becomes n by 2 square by 2. Again, if you go to left or right, it becomes n by 2 cube by 2. And so on. After I steps, it will be n by 2 power I. Is that correct? Is that correct? If I assume that n is of the form 2 power k. So when does this value become 1? When does this value become 1? When does that value become 1?
Equal to k.
When 2 power I equals to n, it becomes 1 or not? When 2 power I equal to n, it becomes 1 or not? N by n, no. So 2 power I equal to n means what is the value of I? Log n base 2. At log n base 2, I equal to log n base 2, what happens? This is roughly not exact calculation, rough calculation. Okay, at log n base 2, what is this value? N by 2 power log n base 2. This is also n, this is also n, it becomes 1, size becomes 1. If key is present there, directly it gives. Otherwise, next iteration, it says that key is not present. So that means total how many times we have performed? We have performed comparison operation. When n equal, for given n, we must have performed 1. When its size is n by 2 also 1 time. When this also 1 time. Even one size is 1 also 1 time. So total how many times we must have performed that comparison operation? Roughly speaking, log n times. Is that correct? The same things we discussed yesterday's class, recursive algorithms. Divide by 2, n becomes n by 2, n by 2 square. Okay, if you have not understood this, still no problem. Let us consider n as total number of elements in the array. N equals to total number of elements. What is that value? If starting index is P, ending index is R, how many elements are there in this array? If starting index is P, ending index is R, how many elements are there in the array?
R minus P plus 1.
R minus P plus 1. R minus P plus 1 elements. So when R minus P plus 1 value, I can say it as n. R minus P plus value, I can say it as n. When there are n elements, okay, no, the time this algorithm takes, that I call it as T of n. When there are n elements in the array, the time this algorithm takes, that I call it as T of n. Now tell me, what is T of 1? What is T of 1? What is T of 1 here? Number of times basic operation is performed. What is basic operation here? This comparison. When when number of elements in the array is 1, how many times that comparison operation is performed? How many times comparison operation is performed?
1 time.
Only 1 time. When it is n value is greater than 1, how many times it is performed? How many times it is performed? Here it performs 1 time, then it goes to either left side or right side. For the worst case, it repeats that process, no?
Log n times.
No. See, when there are n elements, it is T of n time. So how many, whether if it goes to left side, how many elements will be there in the left side? How many elements will be there in the left side?
N by 2 elements.
N by?
2.
If it goes to left side, how many elements will be there? How many elements?
N by 2 minus 1, sir.
You can take one example, It is
Yes, sir. Five elements if you consider.
5 elements. If you consider, it is 2 elements.
Mid element is 3. Yes, sir.
If there are 6 elements, left side, how many
Lower
elements will be
value
there?
1 by 2, I think so.
If there are 6 elements, left side, how many elements will be there? Only 2. Only 2. If there are 7 elements, left side, how many elements? If there are 5 elements, if n equals 5, left side 3. If n equals 6 also, left side is, if n equals 6 also, left side is 2. If n equal to 7, left side 3. If n equal to 8, if n equal to 8, if n equal to 8, left side how many? Still it is 3.
3 only.
Now can you tell me how many elements? If there are n elements in the array, how many elements will be there on
There
the
is
left
lots
side?
of disturbance.
Okay, I think a small. I think now it's stopping. How many elements are there on the left side? Ceiling of n by 2 or Okay, instead of writing ceiling, that is correct. What you said is correct. So number of elements will be ceiling of n by 2 minus 1. Is that correct? That is also correct. What is the other way of writing? What is the other way of writing? Okay, anyhow, this is correct answer. No. So let us go ahead with this. Number of elements on the left side, maximum number of elements will be ceiling of n by 2 minus 1. Ceiling of n by 2 minus 1. Is that okay? Ceiling of n by 2 minus 1. And is it correct? Left side, this many elements. What about number of elements on right side? If n equal 5, how many elements will be there in the left side? And how many on right side? Left 2, right 2. If n equals 6, if n equals 6,
The elements will be on right side, sir.
left side 2, right side 3.
3.
And now can you get, okay, if n equal to 7, left side 3, right side
3.
okay, if n equal to 8,
Left side 3, right side 4.
left side 3, right side 4. Now can you tell me what is the number of elements on left side, right side? You can generalize, no.
Yeah, right side it will be n by 2.
Ceiling of n by 2 or floor of n by 2?
Ceiling of n by 2.
Floor, I think, sir.
Okay, can we say that, okay, sometimes it is floor, sometimes it is ceiling, no, it is changing, no. Can we say that left side number of elements is, sorry, right side number of elements is at most this much? Is that correct? Either we go to left side or right side. Left side means number of elements is n by 2 minus 1, n by 2 minus 1. Right side, it can be, sometimes it can be n by 2. Both, whether we go left or right, number of elements is not more than this, less than or equal to n by 2 elements. Is that correct? Left or right, number of elements is at most ceiling of n by 2. Is that okay? Is that okay? Is that okay, or any doubt? Whether go left side or right side, number of elements is at most n by 2. So that means here the size is not more than n by 2, at most n by 2. Here also the size is at most n by 2. Now in this case, what is the time it takes? If there are n elements, time is t of n. When there are ceiling of n by 2 elements, then what is the time it takes? When there are ceiling of n by 2 time elements, how much time it takes?
C of n by 2.
Ceiling of n by 2. Now what is the total time in this case? One is here. 1 plus amount of work we are doing here. What is the amount of work here? We can write it as not more than ceiling of n by 2, t of ceiling of n by 2. Now finally, what is the reconciliation? What is the reconciliation? What is reconciliation here? T of n, we can write it as not more than 1 plus t of n by 2. Is that okay? Is that correct? Or any doubt in this? Is that correct? Is that correct?
Yes, sir.
What is t of 1? 1. So this is a reconciliation, no? This is general recurrence relation. Okay, no? Recurrence relation. Is that okay? Is that correct? Or loosely speaking, the same thing, some people simply say that this is T of n equal to T of n by 2 plus 1. Okay, no, but it is, okay, no, it is T of n is T of n by 2 plus 1. This also we can loosely speaking, it's not exactly correct, but in the worst case, we can say something like this, no? Is that okay? Okay. Now, how to solve this recurrence relation? How to solve this recurrence relation? How to solve this recurrence relation? In order to solve this, we can assume easy values for n. If n is of the form 2 power k, where k is greater than or equal 0, whether n by 2 is n is always divisible by 2 or not? If n is of the form 2 power 1, 2 square, 2 cube, 2 power 4 like that, ceiling of n by 2, is it same as n by 2 or not? Correct, no? If n is of the form like this, ceiling of n by 2 and n by 2 both are same, no? Both are same. Now we solve this recurrence relation. So it is 1 plus t of simply n, because I assumed it as n equal to 2 power k, so we can write it as 1 plus t of n by 2. Now what is t of n by 2? What is t of n by 2? What is t of n by 2?
1 plus t of n by 2 square.
1 plus t of n by 2 square. Again, what is t of n by 2 square? Here we can write it as 2 plus t of n by 2 square, no?
Yes, sir.
What is t of n by 2 square?
1 plus t of n by 2 cube.
T of n by 2 cube. Okay. So what is t of this?
3 plus
Again 1 plus t of n by 2 power 4.
3 plus 2.
3 plus t of
3
n
plus
by 2
t of
power
n by 2 cube.
3. Then it becomes next
4
again if
plus
you
t of n by 2 power 4.
4 plus t of n by t power 4. In general, after I steps, it will be I plus t of n by 2 power I. Okay. Okay. But we know only what is the value of t of 1. How to get 1 here? In order to get 1,
I equal to log n.
n by 2 power I should be 1. That means what? N equal to 2 power I. That implies I equal to log n base 2. So at I equal to log n base 2, what is that we get? T of n is log n base 2 plus T of n by 2 power log n base 2. Is that okay? What is this value? It is log n base 2 plus T of, what is this value?
1.
T of 1. What is T of 1? Which is given to us? No, it is as 1. So it is 1 plus log n base 2 we can write. But here we have less than or equal to no. So based on that, we can simply say that T of n is less than or equal to 1 plus log n base 2. Okay. What is its order of growth? What is its order of growth? What is its order of growth?
Log n.
It is log n. Order of growth is log n. Order of growth is log n. Okay. So now that means what is this log n here? In the worst case, its order of growth is log n. Its order of growth is log n. Now, if T of n is worst case running time, then can we represent it as big O of log n? Can we represent it as big O of log n? Okay. Is it possible to, is it correct if I represent it as big O of log n? Is that correct or not? Where T of n is worst case running time of binary search. So T of n is big O of log n. Is that correct or not? Is that correct or not?
Correct, sir.
Correct. Okay. Now with whatever we have proved, no, whatever we have proved, it is less than or equal to. That means it is upper bound. That's why we are able, based on this, can we say that T of n is theta of log n? We know
Cannot
that
say,
whether
sir.
it is less than or equal to order of growth is less than or equal to log n. Because order of growth is less than or equal to log n, we can easily write it as big O of log n. But we cannot say this. We don't know, no? We have not proved that. Based on this answer, we can only say that T of n's order of growth is not more than log n. Not more than log n. Okay? That's why if we know exactly its order of growth is log n, then we can write like this. Okay, we can write like this. Now, you look at left side of the array when division takes place, no? When key is not present in that, then what is the size number of elements on the left side? What is the number of elements on the left side? It is ceiling of n by 2 minus 1 number of elements. Okay, it is ceiling of n by 2 minus 1. Is that correct? Ceiling of n by 2 minus 1. That means this is the exact number of elements, no? So now based on this, we can even write that T of n is greater than or equal to ceiling of n by 2 minus 1 plus 1 plus 1. Even if we solve this, still we can show that T of n is greater than or equal to something into log n. That means what? Order of growth of T of n is at least log n. Here we showed that order of growth is at most log n. Here it becomes it is at least log n. So that means what is the order of growth of, therefore order of growth of T of n is exactly, we can write it as log n. Hence, in the worst case, what is order of growth of running time of binary search? It is exactly log n. Order of growth is log n in the worst case. Hence, worst case running time, we can represent it as theta of log n. Now it is correct. With this knowledge, we cannot say this, but if we, after proving this also, we can say this. After proving this also, we can easily say that. Is that correct? So finally, what is order of growth of worst case running time of binary search? What is order of growth of worst case running time of binary search? What is order of growth of worst case running time of binary search?
Log n.
So now let us look at these statements. Okay.
Sir, one question, sir. In the previous slide, no, please.
Please tell me.
In the previous slide, sir, bottom left, T of 1. So how T of 1 is written, sir, here in the bottom left?
This okay. This
one.
that is somewhat simplification directly written. So this value we can write it as equals to, that is equals to n and 2 I can interchange, no? This is 2 power, no?
Yes.
2 power log n base 2. This is 2 according to the definition, we can interchange this 2, no? It becomes n power log 2 base 2. We know that log 2 base 2 is 1. This becomes n power 1. N power 1 is n. That means this n again, this n gets cancelled. That's why directly I have written T of 1.
Yeah.
Is that okay,
Okay.
sir?
Yeah. Thank you, sir.
Okay. Now we know that what is best case running time of binary search? What is its order of growth? What is its order of growth?
N is
N
to
power
0
0.
is constant.
Worst case, what is its order of growth?
Log n.
Binary search, it is order of growth is log n. We know these two. What can we say about average case? It is not order of growth in average case. It is not more than log n. It is at least n power 0. It is in this range. Is that correct? Okay, this is also actually log n. This is also. Now you look at these statements and tell me whether first statement is it true or not. Best case running time of binary search is big O of 1. Is that true or false? Best case running time of binary search is big O of 1. Is that correct or not?
Yes, sir. It is correct.
We only should know what is its order of growth. What is order of growth in best case?
Power 0.
What is order of growth in best case?
N raised to 0.
N power 0. N power 0. That means what? What is that they are finally asking here? Simply the question here is, once you know that its order of growth is n power 0, what is that they are asking? N power 0, is it same as big O of 1? Is that correct? It is same as asking n power 0, is it same as big O of 1? No. Is it true or not? N power 0 is big O of 1. Is that true or not?
True, sir.
That is true. No, linear search also same thing we discussed. So it is correct. It is correct. Best case running time of binary search is big omega of 1. What is order of growth? N power 0. N power 0, can we write it as big omega of 1?
Yes, sir.
Okay. Is that correct or not?
Sir, correct.
It is correct. No, n power 0 is big omega of 1. That is correct. What about third one? N power 0 is theta of 1. Is this correct or not?
Sir, this is also correct.
It's correct, sir.
This is also correct. No, it both have same order of growth. No, that means this is also correct. Now you tell me running time of binary search is big O of 1. Is that correct? That means what?
No.
You should read it as, in the best case also it is correct, worst case also it is correct, average case. That means best, this statement is same as 3. Best case running time, average case running time, worst case running time. Is that correct? If both all three are true, then it is true, otherwise it is false. Best case running time of linear binary search is big O of 1. Is that correct?
False.
Correct. Correct. No. Average case running time of binary search is big O of 1. Is that correct? Or worst case running time of binary search is big O of 1. Is that correct? Worst case running
False,
time
sir.
of binary search is big O of 1.
No, sir.
False, sir.
It is false. In the worst case, it is log n. No, log n is not big O of 1. So here also it is false, here also it is false. Hence, this statement is not true. Not true. What about fifth statement?
Yeah, fifth statement, it is correct.
In the best case, is it true or not?
True.
True. In the best case also it is true.
Average also true.
Average case also it is true. Worst case also it is true. Why? Here n power 0 is big omega of 1. This is correct. Log n is big omega of. We need not even check for average case. If it is true for best and worst, no, automatically it will be true for average, no? Is that okay? If it is true for best and worst, automatically it will be true for average case. Is the point clear why I am saying it is? If it is true for best and worst, automatically it will be true for average case. It is in between these two, so automatically it becomes true. This is small, this smallest, this is largest, it is in between, middle. Okay. Worst case, it is log n. Log n can be written as big omega of 1. That is correct. And hence, automatically for this, it will be correct. So fifth statement is true. What about sixth statement? Okay, we talk about only best and worst. Average, we need not even consider. That's what I said, no? In the best case, what is order of growth? N power 0. N power 0, theta of 1. Is this correct or not? Log n is theta of 1. Is that correct or not? N power 0 is theta of 1. Is it correct or not?
Yeah, best case is correct. Worst case is wrong.
It is wrong. That means, is this statement become true now?
It becomes false.
Is it clear or any doubt? Any doubt in this? Similar things we are discussing for linear search also, no? So shall I move to next? Okay. Now tell me, what about the first statement? Is it true or false?
True, sir.
It is true. In the worst case, what is its order of growth? N. It is log n. Log n is same as big O of log n. It is correct. Here, log n is same as big omega of log n. If it is true, see, once you know what is its order of growth, then only it is nothing but comparing orders of growth. No, log n is same as big omega of log n.
True, sir.
This is also true. Log n is it same as theta of log n?
Yes, sir. True.
This is also true. If I say that running time of worst case running time, it is big O of n square. Is this true? Worst case running time of binary search is big O of n square. Is that true or not?
True, sir.
Yes,
It is true, but nobody writes it this way. Similarly, worst case running time of linear search is big O of n. Is this true? This is also true. This is also true. But what type of bounds big O gives? It is upper bound. Upper bound should be as small as possible, no? As small as possible. Hence, only this is preferred. Smallest is this. These are correct, but nobody uses this. Use this. Okay. Next. Similarly, what about fourth statement? Is that true or false?
True, sir.
It is true. It is true for best case also, worst case also. we need not even check for average case. In the best case, what n power 0 is big O of log n. This is correct. In the worst case,
Log n is equal.
log n is big O of log n. This is also correct. Average case, automatically it becomes true. What about fifth one?
False, sir.
False. So why, sir? For which case it fails?
For the best case.
In the best case it fails, no? In the best case it is 1. 1 is big omega of log n. This is not correct. This is not correct. What about this one? So hence this statement is false. This is correct. All are true. What about this one?
False, sir.
1 is theta of log n. This is also false. Hence this statement is also false. Is it clear? Is there any doubt in running time calculation of binary search algorithm? If the worst case running time of binary search, if the recurrence relation is given like this, T of n is less than or equal to some constant plus T of n by 2. Okay, no, floor or ceiling. Okay, is it right or wrong? Is it right or wrong? And T
Right,
of
sir.
1 is some constant.
It is right.
It is correct. Okay, no, it is correct. Even this form also, okay, correct. Not only here one should be there always, one and all. It's not like that. Okay, even other operations count, it is taken into consideration. Still, this is correct. But after mentioning worst case, even if it is written as T of n is 1 plus T of n by 2, still we can consider it as correct. Once if they mention it as worst case. Okay, no. But exactly if you want to write, we can only write T of n is less than or equal to T of ceiling of n by 2 plus 1. So in the exams, no, they give reconciliations in different form, but all they mean the same only. Okay. Now tell me, is it a recursive algorithm? Yes. What does this algorithm find? What does this algorithm find?
Nth Fibonacci.
Nth Fibonacci number. Nth Fibonacci number. So what is most important operation here?
Step 2. If n is equal to 0 or
Okay, this one. Okay, fine. Okay, let us consider this operation as most important operation. So let T of n be the number of times this operation is performed. T of n is number of times. This is that I can call it as comparison, no? Operation is performed. Operation is performed. Okay. Now what is T of 0? What is T of 0? What is T of 0?
1, sir.
What is T of 1?
1 ohm, sir.
T of 1 is also 1. T of 1 is also 1. So therefore, what is T of n? What is T of n now? it is amount of work done here. That means if n equals 0 or 1, directly we stop here only. Otherwise, if n is greater than or equal to 2, first this condition is checked. This condition fails. That's why we go to else part. We go to else part. Okay, else part. So that means this is performed one time first. After that, we perform this operation. We make this recursive call also. If n is input, number of times this operation is performed is T of n. If n minus 1 is input, how many times this operation is performed? T of n minus 1 times. If n minus 2 is input, how many times it is performed? T of n minus 2 times. Is that clear? Is that clear? Is there any doubt here?
No, sir.
N is greater than or equal to, what is T of n? T of n can be written as T of n minus 1 plus T of n minus 2. If n is greater than or equal to 2. Okay. So this is our reconciliation. Okay, usually we write this the other side. Okay. This is our reconciliation. So T of n equal to T of n minus 1 plus T of n minus 2 plus 1. If n is greater than or equal to 2, T of 0 equal to 1 and T of 1 is 1. T of 1 is. So this is reconciliation for the running time of this algorithm. This is reconciliation for running time of this algorithm. Now we need to find what is its order of growth of T of n. Order of growth of T of n. What is order of growth of T of n? What is order of growth of T of n?
So need to solve recurrence relation.
We need to solve this reconciliation. Okay, because we don't know how to solve this. Okay, we let us consider this reconciliation. Fibonacci sequence, what is the reconciliation? Fibonacci sequence, what is the reconciliation? Last class also we discussed, no? F of n is f of n minus 1 plus f of n minus 2. If n is greater than or equal to 2, and f of 0 is 0, and f of 1 is 1, no? Is that okay? That is our sequence, no? 0, 1, 1, 2, 3. Is that okay? Okay. Now, how to solve this reconciliation? It is of the form f of n minus f of n minus 1 minus f of n minus 2 equal to 0. Equal to 0. You must have heard about solving reconciliations using characteristic equation method. Do you remember what is characteristic equation method? Characteristic equation method. Do you know what is characteristic equation method? Okay, characteristic equation method. That is, in general, say if we are given a reconciliation an plus some constant a1 into an minus 1 plus some constant a2 into an minus 2 plus and so on plus some constant ak into ck into an minus k equals to say 0. Okay, where
So is it not like a0 into x raised to n plus a1 into x raised to n minus 1?
It is something like that only. Correct. Okay. I just give one example so that I think you can recall. Okay. So this is it where C1, C2, C3 and so on, Ck are constants. Now, is it a recurrence relation or not? First of all, is it a recurrence relation or not? Is it a recurrence relation or not? Whatever is given here, equation 1. An is nth term. N minus 1, n minus 1th term in the sequence. It's a recurrence relation, no? So, is it a linear recurrence relation or not? Is it linear recurrence relation or not? Yes. Why? Because we represented an as a linear function of sum of its previous terms, no? Sum of its previous terms, an minus 1, an minus 2, an minus k. K of its previous terms we represented as a linear combination of this. So that means, first of all, it is a recurrence relation. What type of recurrence relation it is? It is a linear recurrence relation. And here, this value equal to 0, no. This value equal to 0. It is represented in terms of its previous terms, but no other function here. No other function which is, okay, no? Function here. This value is 0. Then this type of recurrence relations we call it as homogeneous recurrence relation, no? So that means we are actually given linear homogeneous recurrence relation. Here, what are these? These are coefficients, no? These coefficients that these are what type of coefficients? These are coefficients which are constants. That I call it as linear homogeneous recurrence relation with the constant coefficient. How to solve linear homogeneous recurrence relations with constant coefficients? In order to solve linear homogeneous recurrence relations with constant coefficients, that given linear homogeneous recurrence relation with constant coefficient, we write characteristic equation. We write characteristic equation. What is characteristic equation? Here, associated with the given recurrence relation, it is a polynomial. What is the order of this recurrence relation? What is the gap between nth term and the smallest term given here?
Yes.
K. So order is K. So we will get a polynomial in, say, some value, say R.
Yes, sir.
Polynomial R. It is R power K
R
plus constant.
K
Okay,
minus
C1 into R power K minus 1 plus next constant here C2 is there, no, C2 into R power K minus 2 plus and this one Ck into R power K minus K equal to 0. This is a polynomial in R whose degree is K. Whose degree is K. Why this K? Why? Because here an is represented in terms of K of its previous terms. Not only that, the smallest term here is n minus K. Hence, the gap between this is K. That's why R power K. Is it clear?
Yes, sir.
Okay. Anyhow, even if it is not clear, that example, no, we again apply that so that it will be more clear. Okay. Polynomial in R degree is K. Now, how many roots this equation will have? This polynomial, number of roots?
K roots.
K roots. Number of roots is K. Number of roots. All K roots may be different. R1, R2 are roots. Roots are R1, R2 like this. R1, R2, R3. All K are different. If all K are different, solution to the corresponding recurrence relation is given by an equal to some constant to d1 into root 1 power n plus some constant to d2 into root 2 power n plus some constant to d3 into root 3 power n plus and so on plus some constant to dk into r root k power n. Is that okay? Is that okay? Okay, there are other cases that we'll discuss later. There are other cases which that we'll discuss later. Okay, one. Okay, we need only this part. We need only this part. Last minute, then will have break. So if you this reconciliation you compare with the equation 1 here. What is an? What is an here? What is an?
F of n.
What is an minus 1 here? F of n minus 1. What is an minus 2 here? F of n minus 2. Okay, now it is of this form, no? an minus 1. What is C1 value? What is C1 value? What is C1?
Minus 1.
Minus 1. This is C1 C1, no, that is minus 1. What is C2?
Again, it is also minus 1.
It is also minus 1. What is value of K?
2.
It is 2. Is it clear? At least this time up to this, is it clear? K equal to 2. Is that clear? Now you tell me what is characteristic equation corresponding to this?
R square minus
R square
minus R minus 1 equal to 0.
minus 1 equals to 0. Is that correct? Is that correct? Is that correct? Correct, no. So why? Because here, okay, again exact form I write whatever is written here, r power k. What is r here? What is r? R is same variable that we are taking. K. What is k? It is r power k plus c1 into r power k minus 1 plus c2 into r power k minus 2 equal to 0. Is that correct? It is of this form or not? It is this form or not? Is that okay? Because if you compare with this, no. Is that correct? What is k value? Now we know that it is 2. R square plus c1 into r power 2 minus 1 plus c2 into r power 2 minus 2 equal to 0. Now you substitute c1 value and c2 value. R square, what is c1? Minus 1. R power 2 minus 1, that is r only. What is c2? Minus 1. R power 2 minus 2, r power 0 into r power 0 equal to 0. What is this? R square minus r minus 1 equal to 0. Is that correct? Is that correct? Okay, I just stop here. We'll have break. Again, we'll assemble at we'll continue at 6:35. Okay. Okay. Thank you.